Hi, welcome back to the Network Plus Certification video series. I'm Mike Redmond, Master Trainer, here to help guide you through your successful journey of becoming a Network Plus certified technician. We're going to walk through a wide variety of topics, starting with basic network concepts all the way through network management and security. Next, we're going to take a look at applying the practical skills you've learned throughout these modules. We're going to take a look at how to install and modify a medium-sized space spanning multiple buildings. Design needs to include structured cabling, wireless, operating systems. Consider your internet connectivity and what type of network or system security you're going to require. And we'll also discuss the implementation of an industrial control system such as a SCADA system. It all starts with basic network design. When designing a network, there's a certain methodology that you must keep in mind. It follows a series of logical steps. We're going to walk through each of them one by one, starting with requirements and different types of device requirements, on through compatibility issues that we might need to consider as we design the total infrastructure. Starting with the list of requirements, this is a list of the network needs. Why are you installing this network? What are the primary features that are going to be required? What are the device types and requirements for this network? How should it be logically organized? Are there any environmental limitations that we need to consider? HVAC and humidity controls come to mind. Are there going to be some equipment limitations that you're going to have to take into account? Are you going to use existing equipment? Are you going to use existing applications? What type of cabling standard is going to be required not only by the customer, but perhaps by local law? You'll need to consider any compatibility issues. What types of devices, new and old, that's going to possibly limit the choices that you make as you begin to build this infrastructure out. Are you going to include wireless technology, or will it just be a wired infrastructure? If it will be wireless, are there any limitations on frequency and band? What are the possible sources of interference? And then, of course, security issues. How are you going to deal with the computer and the data and the overall network security? These are all the things that you need to consider before you even purchase your first network device. So let's start by trying to define some of the network needs. It starts with size, and if you've ever bought a house, location, location, location. This will set the stage for the physical factors of the building itself, the home in which all this infrastructure is going to live. You'll need to determine how many servers, if any, you possibly will be using cloud services. What services are going to be needed that are going to live in this facility? You'll need to determine the host and server operating systems. Will it be exclusively a Windows environment? Will it be a mixed environment? Will you house many operating systems? The type of server infrastructure will then be dictated almost by the host operating systems. What type of additional hardware and software is going to be required? Everything from badge readers and prox readers on through specialty software, depending on the organization and the business needs. So let's start by building out a fictional organization. We'll call them Balin Widgets. They have a need. We're going to build them a network. There are going to be several individual offices that need workstations that are going to do very specific jobs. The company needs servers that can handle anything that's thrown at them. The building needs internal cabling. The building's need for an intermediate distribution frame, or IDF, to provide for communications, and the building is going to need fairly solid connectivity. So it all will start with a diagram. You'll sketch out your network diagram, both physical and logical diagrams, not only the physical equipment, but how logically will the data flow through the network infrastructure. You'll need to begin to consider asset management. This is a detailed inventory of the software present on all the servers and workstations. This will include versioning, any upgrade paths, and licensing costs associated with them. You'll need to then begin to identify your IP address utilization. You can create and maintain pretty much your own IP table for your own physical and virtual infrastructure. However, the planning starts at the beginning. How are you going to chop up and subnet this network? Next, we'll need to obtain and maintain all vendor documentation. Everything that comes with every piece of equipment should be properly stored and cataloged for later reference. Most organizations, by the time they get to this point, when you're beginning to build out a new network, they have existing operating procedures and policies and standards that they had gone by. Very few businesses just jump into a physical building before they have a standard operating procedure or an SOP or several AUPs for their users to sign. And how do they govern the escalated privileges and the GPOs that you will ultimately end up having to enforce on your server infrastructure? Now that we've considered this, it's time to build our network. So, everything starts with a good idea. Network design is no different. Through our network design, we quantify or put a number on how much equipment are we going to need, how many operating systems are we going to support, and how many network applications are going to run throughout the infrastructure. This is going to include workstations, servers, the equipment room itself, and any associated peripherals. For instance, with the workstations, you'll need to know an employee count. Do you need one for each employee? Or are there some specialized employees that possibly need 2 different workstations at their desk? Are there specific or standardized OSs that you need to take into account? Can everyone just have a version of Microsoft Windows 7 Enterprise? Or are you going to need, for instance, specialized CAD software that will be highly resource intensive? And of course, considering the different variations of operating systems. Some employees may prefer Windows, or some prefer Mac. Some may even prefer Linux, or the organization's business may dictate the specific platform that you install. When it comes to servers, it's a different checklist. With servers, you need to identify how they're going to do network authentication and network management. You'll have to set up accounting, otherwise known as auditing. File management, are you going to include redundancy and backup, or how much? Are you going to provide intranet services, such as an internal wiki or possibly a SharePoint environment? Are you going to need to have a separate environment from the main production environment that there will be web testing or product testing going on? Any type of development environment should be isolated from the main production environment. Are you going to need software repositories? If this is, for instance, a business that writes software for a living, well, those software designers are going to need repositories to keep versioning of their software. Next, the equipment room. It's important to take good measurements within the equipment room. Scale out everything. You need to know exactly how much space that you have to deal with. And here's especially where local and state law will begin to dictate, for instance, how wide your hot and cold aisles have to be, what the fail-safe or fail-secure measures for doors need to be. You'll need to take into account the environmental factors. Remember that data centers have a tendency to be very hot. So how are you going to handle temperature and humidity control, airflow throughout the equipment room itself? How are you going to manage physical access control? Are you going to have a combination on the door, or will there be a prox reader? Well, that's going to take consideration before you start installing equipment. It's a lot harder to do these things after the fact. What are your power consumption requirements? Remember, data centers, again, they use a lot of power. Do you have enough clean power being provided to the facility to allow uninterrupted service to the organization? If not, you may need to consider a line conditioner or UPS backups. Cable management. Remember, we've talked about good cable management, not only for cable management's sake, but it's a safety concern. You don't want people walking through the equipment room and tripping over cables and hurting themselves, or possibly even unplugging a mission-critical server. Next is the consideration of peripherals. Now, of course, this is going to depend on the size and needs of the network as to what type of peripherals you're going to include. But you'll also need to take into account the capabilities, varieties, depending on what the organizational need is. For instance, do they have a requirement for a centralized print room, or is everyone going to have a side-by printer next to them? Or perhaps you're going to employ a 5-to-1 rule. Well, that's going to require additional drops if these printers will be networked. You see where I'm going here. Next would be, for instance, to consider any fax machines that you may need. Yes, there are still a lot of organizations that will only send and receive documentation via fax. If this is the case, this means you're going to need additional phone lines, and you'll have to consider that again as you're building out your equipment room, and where are those lines going to run and through which cable trays, and how will those lines be marked. Next is to consider any compatibility issues. You're going to be buying a lot of new equipment. Are you, for instance, moving into a new facility with old equipment from a prior facility? Sometimes you'll run into what's identified as end of life, end of service. You can't get the same model, for instance, of the equipment that you already have, so you're going to have to buy the new model. Is it compatible with the old equipment that you already have? There is a grave concern of backwards compatibility issues, especially when migrating networks. Now we'll consider what internal connections there are going to be. Switches, structured cabling, electrical and environmental limits of that cabling. How much and how much is it going to cost for instance, plenum wiring? Where are the plenum spaces that are going to require this wiring? Next, WAP placement. It's a lot easier to install wireless access point first before you start putting in drop ceilings. Network segmentation. How many VLANs do you need? How many different organizational units are there within this infrastructure? This should all be planned out up front as well, and that will lead you to your IP address scheme. You don't want to make your subnets too small because then you don't have room to grow. You don't want them to be too large because then you'll end up wasting IP addresses. So let's talk about each of these individually. When it comes to switches, you'll need to consider, for instance, power over Ethernet requirements. If you plan on installing wireless access points, that means you're going to need power over Ethernet switches. However, if you're not going to install wireless access points, you could probably save money building out the infrastructure because it's a feature that you just don't need. Next is your structured cabling. Remember, I told you that all organizations must meet a standard when it comes to structured cabling, like clearly labeled runs and identifying how long those runs are. Remember, depending on the type of media you use, they have maximum distance before you start getting attenuation on the line. It's always a good idea to make a drawing, a floor plan, showing these runs and showing the workspaces and showing where each of the individual drops are. Next, with electrical and environmental limits, again, you need to take into account your humidity and temperature requirements. A data center should be kept no warmer than roughly 68 to 72 degrees, and computers like cool, dry areas. High humidity would bring moisture. Moisture in electrical equipment usually doesn't mix. What type of fire detection is going to be required? Are you going to need a wet pipe system or a dry pipe system? Are you going to need a hybrid like a deluge system? Again, at the building out of the infrastructure, this is the time to take these kind of things into account. Here, for instance, is a basic floor plan drawing showing the cables and the types of cabling and drops that are going to be in each functional area, as well as how each building across this campus is going to be connected, what type of equipment is going to connect them. Drawing this out up front, it really will save you a lot of heartache down the road. Next, we'll deal with the internal connections, wireless and VLANs. Where to place the wireless access points inside the building is almost as important to consider as how far does the signal go outside the building. Remember, you can't often keep a constant watch on the outside of the building. You don't want someone hanging out outside in your parking lot sucking up your wireless bandwidth. Another consideration is if these buildings, for instance, are near an airport. You're going to have frequency and band considerations that you'll need to also begin to take into account. What type of encryption and authentication are you going to use? Again, the standard, or at least the de facto standard, would be to select WPA2 Enterprise. However, when we spoke about the servers, did you include the Radius server? And VLANs, segregating particular users from the rest of the population, like programmers and researchers. Their data should be absolutely segregated from the admin assistants and HR. HR should probably be segregated within itself between hiring practices and disciplinary. Accounting, it probably are going to want to VLAN accounts receivable and accounts payable. How many people are in each one of these organizational groups? This, again, is going to dictate how large those VLANs are, where you're going to draw your lines of segregation. So now our drawing is truly starting to take shape. You see our wireless access point placement, our interconnection between buildings, where individuals are going to sit, what type of connectivity and cabling that they're going to have, what function each space is going to play. When considering your network management, now this is where those additional servers will begin to come in. Are the servers going to be, for instance, on their own VLAN? Well, that's probably a good idea depending on what the function of that server is and how protected it needs to be. You're going to have some servers, for instance, out in the DMZ, which dictate a separate VLAN from your main primary internal scheme. That IP address scheme, you'll need to figure out whether you're going to use NAT or PAT, whether you're going to use DHCP or static addressing, or a hybrid of both. Next comes the selection for external connectivity. It doesn't do us any good to have a high-speed internal network if no one can get to the internet. There are only certain ISPs that can provide you the bandwidth, depending on an organization, that you may require. You'll also need to consider redundant paths. This often is overlooked. A lot of organizations will get a primary path in, but then forget that primary paths, just like all technology, it will fail. How are you going to maintain business continuity when your primary ingress-egress does not get out of the building? Even a simple dial-up backup path could at least keep a business operational while the main path is being worked on. Another thing to consider is whether you're going to require fiber or and what kind of connection. Is a standard Metro Ethernet connection going to suffice? Or are you going to require additional types of connections like SONET or MPLS? While the installation is less expensive and the syncing of local data is a lot easier, it also does come with the price. You need to know how to administer this type of environment. It will take specialized equipment. Next, we'll talk about unified communications. Unified communications simply is TCP/IP communications that encompass a range of different technologies, voice, video, and messaging. Unified communication features reside, for the most part, on real-time services or RTSs. Unified communication protocols, however, would be things like VoIP. With real-time services, you are going to deal with multiple services, like presence information. This enables users to show that they are present for some form of communication, like video conferencing. Most all enterprise level video conferencing is going to use multicast-based video streaming for presentations. However, this brings into another consideration. If you are going to permit video conferencing, and a lot of organizations do, you're going to need to consider making sure the clients are authorized for multicast streaming. Next would be real-time video. This enables full bidirectional video streams. This is usually what most people are familiar with when they think of a VTC. Also considered in real-time services are faxes, desktop messaging, and collaboration tools and workflow tools like Microsoft SharePoint. Next are the unified communications devices. These are handling your voice and video. And of course, when you have all of this software and all of this hardware, now you have servers. These servers are usually dictated to be dedicated boxes that support only unified communications. You generally don't want to put, for instance, your VoIP services on and cohabitating with an email server. Next will be some network infrastructure specific gear, like the gateway devices, an edge device, sometimes dedicated, but often it's really nothing more than a few extra services adding to an existing edge router. However, you'll need to consider the power and horsepower and model of your edge router, and can you add those extra services, or are you going to be required to buy an additional dedicated service? Now, since we're talking about routing traffic, let's take a look at the Unified Communications Protocols. Real-Time Transport Protocol, or RTP, resides on TCP port 5004 and 5005. The Session Initiation Protocol, or SIP, resides on TCP port 5060 and 5061. H.323 you will find on TCP port 1720, and the Media Gateway Control Protocol, MGCP, is on ports 2427 and 2727. So along the same subject is how and what ports you're going to route traffic through will be some additional considerations that you'll need to consider, like a MediaNet. Your MediaNet will use your QoS services or quality of service. How complex or simple it is usually dictated by the organizational need. For instance, if the organization provides a lot of external training to external individuals, your MediaNet is going to need to be a little more robust than simply providing PowerPoint presentations over streaming media. Next is video teleconferencing. This is one of the items that are carried by the MediaNet connection. We used to use ISDN lines. However, ISDN lines are expensive, and considering all the other technical options that we have, there's really no need for the additional expense of an ISDN for a simple VTC. Mainly because we have IP over SIP. This allows for the connection for our VTCs to travel the high-speed internet. That's a pretty important point to maintain, because with the ISDN lines, we were pretty much capped at 128 kilobits. So let's take a look at specifically how you need to configure your quality of service. This is configured by what's identified as diff serves. It's the underlying architecture that makes quality of service work. How it works is each data IP header contains two diff serve data pieces. The first is the ECN, the explicit congestion notification, and then the second, the differentiated service code point, or the DSCP. So dealing with the ECN, it's a 2-bit field that is simply making sure that the network infrastructure is congestion aware. You'll set this 2-bit field with either 00, 01, 10, or 11. 00 is not QoS aware. That's usually how most infrastructure devices are going to come configured by default. 01 is QoS aware with no congestion. 10 is again QoS aware with no congestion, and 11 QoS aware with congestion encountered. The differentiated service code points are the next 6 bits that complete your total 8-bit packet. This is your class of service. It's a value that is applied to the services and ports. Next, we'll talk about the industry control systems. It's an overall system that monitors and controls usually large machinery and sometimes specialized machinery. There are 3 basic components. The input-output, those work through sensors and actuators. The sensors monitor the elements such as temperature or power levels. The actuators make the changes to elements, like turning off and on heaters or increasing voltage or making pumps work. Next is the controllers. This is the computer that can maintain the established parameters of all these design systems. Start thinking of an electrical power plant. Next is your interface operator. This allows the user to monitor and or intervene, if necessary, all of this equipment that must be maintained at precise levels. So within this environment, you will have a distributed control system and programmable logic controllers. The distributed control system is a small controller that is directly installed on each machine. It distributes the computing load and connects back to the centralized controller. The programmable logic controller is the computer that controls the machine, the actual computer that does or indicates how to do the thing that it's trying to control. It enables workflow to follow specific ordered steps. So a smaller yet somewhat related subset of these types of systems are called SCADA, Supervisory Control and Data Acquisition Systems. The same base components of the DCS, except they're designed on a much grander scale. Power grids, railroads, pipelines, nuclear power plants. Here you'll find remote terminal units. They take the place of the controllers that you saw in the ICSs. They can use long-distance communications for telephony services or fiber or even cellular. Maintaining constant contact with SCADA systems can sometimes be a challenge, but absolutely required. With SCADA, the one and probably guiding principle that you're going to have to follow is segmentation. Segmentation, when it comes to the other benefits of your network segmentation, is your ability to optimize performance through reduced congestion and load balancing. Remember, these are very large systems maintaining a power grid. You don't want that data competing with your email asking what time we're going to lunch. So how does SCADA systems fall into and in relation to the existing OSI model? Well, the physical layer, or layer one, physically separating your network from every other network. This is known as air gapping. Most SCADA systems are going to be air gapped systems. They're not directly interfacing with any other network component within a larger production environment. Layer two, at the data link layer, separating a physically connected network into separate broadcast domains. You can think of VLANs with this one. Essentially, you're creating a air-gapped VLAN. Layer three, the network layer, you're actually separating broadcast domains by blocking, denying certain IP routes. And then above layer three with VPNs and separate SSIDs, if you do have wireless and Windows domains, well, those really don't come into account very much with SCADA systems because, bear in mind, a lot of the SCADA environments are still operating on what we would consider on modern networks antiquated operating systems. They don't get updated very much. There are some SCADA systems still operating with Windows 98 and Windows NT. But because they're stable, they don't get upgraded and they don't really get messed with. And because we've taken the pains to air gap into SCADA systems, you can't just remote into many of them. You enjoy a little bit of added protection there. However, it is widely considered that the SCADA systems, because of the age of them, are the next hurdle for us to overcome when it comes to network security.
Well, there you have it. Pretty simple, right? I know, it can be a lot of information coming at you all at once, but don't worry, I'm here to guide you every step of the way. You can do this. Just remember, study hard, lots of practice questions, and you will succeed. You will become a Network Plus certified technician. I'll see you next time. Well, there you have it. Pretty simple, right? I know, it can be a lot of information coming at you all at once, but don't worry, I'm here to guide you every step of the way. You can do this. Just remember, study hard, lots of practice questions, and you will succeed. You will become a Network Plus certified technician. I'll see you next time.